Okay, so now what I promised is IP address assignment. So this is a little bit of art process. It's not really art process, but it's kind of interesting, and you probably want to do this exercise a little bit mentally because it's kind of interesting process. So first of all, when we assign in the subnetworks, there are a few basic questions. What resources are available? Like that's the first question that would be asked by anybody. This usually is not really a question, because if you setting up the network, you go to ISP, and ISP basically giving you, if you're lucky enough, it will give you a set of like one block of IP addresses, and by one block I mean is a subnetwork of some designation. And you can assign this, you can start using this block and sub-allocate in some way in order to actually put all the hosts that you want to communicate within the allocated resources to you. So that's kind of basic idea behind the subnetting that we talked in the previous part. And there are a few considerations, obviously. So one option, if you just use the whole subnet that was allocated to you, that's kind of okay, assuming you're not planning to do any additional network management, or like sub-networking inside your home. So like if you just had one Ethernet, for example, and everybody communicating with everybody, this would work. But as soon as you have a network that is a little bit more complex, as soon as you introduce a single router in the system, then you immediately have to kind of ask for more blocks. And if ISP just doesn't have enough IP addresses, then you are in a little bit of pickle. So what basically you can do is to try to constrain the resources, like conserve the resources. So for example, you can use longer prefixes, but then you have to also consider the fact that there's a status quo, there's a number of hosts that are currently communicating, and you may need to have some reserve for the future extension of the same subnetwork. So for example, if you pick the /30, you probably already figure out how many hosts can communicate. And I'm just not trying to give out the answer for the question that I asked in the previous part. So there will be very limited hosts that can then communicate. And if you want to add additional hosts at some point in the future, then you basically will have to kind of redo the whole process. So you still have to like renumber all the hosts, or even kind of in the worst case, you have to move to a different subnetwork that is not even adjacent to this one. So it needs to be done cautiously. But basically that's it. Additional note here about the subnetworking. The subnetworking technically is always a decision of a local node. So remember, when I show you the picture of kind of automatically created entries, this was those entries were coming from the configuration. So I configure IP address, I configure a subnetwork, and this automatically creates an entry. And so like whenever I'm trying to send a packet to one of the IP addresses covered by the range, I will be able to send this packet directly. But this property is individual to individual nodes. It would be misconfiguration, but it is still possible to kind of configure on one side the same subnetwork with /24, and on the other side almost same subnetwork but /25. It is potentially a problem. It wouldn't be a problem for some number of IP addresses, but would be a problem for some other IP addresses. And I'll try to put this question as part of the homework so we can get a little bit more idea about this one. But in any case, back to our assigning of the IP addresses. So let's just put a few restrictions. So because we always have some kind of knowledge of how many hosts we would have in specific networks and what we want to communicate, what we want to do or how we want to communicate together. Like for example, whether the subnet 4 wants to communicate with subnet 1 or not, because it's depending on the answer. You would have different IP addresses would be still different, but it also may have a different routing entries. There are tons of different ways how to solve this specific problem, and first of all, it also depends on what is the resource available, as I mentioned before. For example, if I gave you the resource of this /16, like a 10.100/16, meaning that the first two octets represent the network, and then you basically have freedom to pick anything else afterward. For this environment, you kind of out of luck of using the whole /16. Because you have 4 subnetworks and they have to be on separate subnetworks, so you have to have them separately. So what you can do? Obviously, you can, let's say, I'm not sure. Again, there are tons of different ways, but the example I'm trying to show you is to have some knowledge of conservativeness in IP address assignment. So we kind of in the example what I'm showing you, we're trying to pick subnetwork like sequentially using up the assigned block that can contain that number of hosts that we put as part of the requirement, but not too much. Like basically just this many, but wherever they can fit in actual single subnetwork, because you cannot have subnetwork for exactly 150 hosts. You have to pick wherever the closest power of 2. For the subnet 1, in my imagination, just pick the 10.100/22 that can contain up to 1024-2 hosts. So basically, these 2 addresses, the first and the last, cannot be used in this case, but we don't need them because we only need to support up to 1,000 nodes. So kind of basically fit the requirement, but we didn't kind of use too much of the IP addresses. Okay, so done with the subnet 1. For the subnet 2, I'm picking next available. So maybe you need to give me some small explanation of why exactly the next available become 10.140 and /26. So give me that answer at some point. And for that host, I basically need up to X amount, up to 50 IP addresses, and if I can imagine, 50 IP addresses would be covered by the subnetwork of 64-2 hosts, so I'm picking /26. And I hope you can confirm that the /26 is for 64-2 hosts. The next one is a subnet 3. So this one is a little bit special, and I hope you're getting used to all this terminology. So if it's really point-to-point link, and there is a guarantee that there will never be more than 2 hosts on this network, then you can safely pick the /30. I forgot exactly why I picked the number, like why I started with the 4,252, but basically I was trying to make sure that I still can use some portions of 4, but that comes before, that comes after whatever the last IP address in /26, but before the first IP address of 255.30. So there is a small block of IP addresses that still can be allocated at later point of time, either to like /27 at some point, or some basically other point-to-point connections at some point. Finally, for the subnetwork 4, given the requirements, I pick /24 that can support up to 256-2 hosts, and basically that's what needed for this case, and that's the smallest subnetwork I can pick for this purpose. And as you can see, we didn't waste too much of the resources. We still have a tons of IP addresses available for future assignments, like if we expand this network further, or I don't know, like if we need to do some form of renumbering or like extension of existing IP networks. So this one is basically the core idea behind the assignment of the IP addresses. This is quite a simple example when we pick one subnetwork, but there can be more complex examples when you give in a couple of subnetworks and you have to figure out what to do with those IP addresses and how to split those subnetworks. What you have to, I didn't put it on a slide, but I'm assuming you have a reasonably good understanding of how this configuration would affect the routing table on each of these hosts and routers. So for example, for the hosts in the subnetwork 1, a host and the router itself would have a routing table entry that corresponds to 10.1.0 some IP address because it was assigned, but it still will be 0 as part of the routing table, /22 saying that it's accessible directly over that specific interface. And interface can be named differently depending on a specific system. But again, all hosts plus the router will be part of this subnetwork. On subnetwork 2, on the picture, the host and the router will be part of this second subnetwork and will have the specific routing table entry that designates directly reachable. And similar for subnetwork 3 and similar for subnetwork 4. Depending on the objectives of the network, you may need to have additional routes available on hosts, on the routers, in order to set up the routing between subnets. Because if we don't add anything special beyond what we already created automatically, then you only be able to communicate within the subnetworks, but not beyond. As soon as you create some kind of default route or some other types of routes, then you can start talking beyond a single subnetwork. But so that's kind of the basic logic, basic concept of IP forwarding. Okay, I hope it was quite interesting, but I understand it's a little bit heavy to remember, but you have to have very good understanding of IP address assignments. So this one is directly related to routing table, because subnetworks, everything is all related to the routing table, plus it's a little bit related to the availability of the IP address resources. Like with IPv4 addresses, we have reasonably limited resources available today, so you have to be very mindful in when you're assigning. So I'm a little bit hand waving here, because in some cases we have this private IP addresses that have like huge availability. So for example, the one I was using, 10 something is a part of the private block, which have plenty of resources, and you can use them as part of the private networks in whatever way possible. But if I'm talking about the publicly routable IP addresses, like the one that sometimes you get if you connect it to FIU network, then those resources are really limited, and you have to manage them very carefully. Okay, so it was a little bit intensive, but that's it for this part, and see you next time.